we will do, today's topic is some applications of Newton's third law. Okay, so before that I need to do one more topic. Okay, let's say, so which out of the three law, which one do you think is the main law? Which is the most important law out of the one, and which contains all of them, all the two laws? It is the second law. Second law is a real law of motion. The real law of motion. How can you say that? You see, we know what? As you know, force is equal to mass into acceleration, right? If F is equal to 0, means what? Mass into acceleration equal to 0? Means mass cannot be 0, right? That means acceleration is 0. That means d square, that means dv by dt equals to 0, or dv equals to 0. If I integrate it, I should get here what? V equals to constant. So isn't this is the actual law? You can see that means, isn't this saying that when the body is not accelerating, it is either at rest or it is moving with a constant uniform velocity, right or not? So this is the first law. First law from the second law. This is how you derive it. What about the third law? Again, I can write F equals to mass into acceleration, right? We can write, if we consider two objects. Now for third law, consider two objects. They are colliding with each other. This is A, this is B. Clear? So let's say force exerted on B by A will be what? It will be change of momentum. When B will impart, when B force on A, when A will push B, B will give rise to a change in momentum. Similarly, when B pushes A will come to a change in momentum. Am I right?
Yes.
So total, if I add them, what should I get? Right?
Yes.
Right? Total momentum, isn't it? In absence of external force, F of BA, because whenever external force is there, then only the body is what? Accelerating, right? So when this is 0, then what can I write? Right?
Yes.
Isn't this the third law? Clear?
Yes.
May I clean it?
Yes, sir. Yes, sir.
Okay. Now, apparent weight of a person in an elevator. So, you consider a lift. This is the lift box. I'll show you free body diagram. Now, what is free body diagram? I will come to that. Right now, let's start with this one only. Is that I'm going to just draw the forces that is acting. Okay? And considering the object, whatever be the object, as a form of a box, and then representing all the forces acting on it. Okay? So we'll talk about more free body diagram in the upcoming videos. So now, this is the person who is standing here. Now his weight is mg downward, and according to the Newton's third law, there is also reaction force R. When both of them are at rest, not moving, they are at ground level, they are not going up. When both of them are at rest, at that time R equals to mg. Right?
Yes.
Now, case 1. When the lift moves upward, when the lift is moving upward, with an acceleration a, means now you are going up. So I will draw the free body diagram here. Try to understand. So the lift is going up with an acceleration. So this is the acceleration up. So now what do you think it would be? How will you draw? How will you write? Already R and mg is there. Right? So how can you write now? Now you see, as you are going up, that means the net displacement is, net result is upward, right? That means R minus mg is equal to mass into acceleration. Is it or not? When subtracting these two, when you are getting the rest force, that remaining force is responsible for your acceleration of going up. Am I right?
Yes.
Then R would be equals to what? M G plus A. Means, what does this mean? If a person's weight is, so normal reaction is this one, right? Normal reactions. So if a normal person's weight is, so what do you think would happen now? So what do you think? What is happening?
The weight of
The
the
person's weight increases. So if one person is weight is, let's say, 50 kg, and the acceleration is, let's say, 2 meter per second square, so you can guess 50, 10 plus 2, that gives me 12. So 50 into 12, how much is this? Around 600 Newton. Whereas it was, for only G, it would have been 500 Newton. Right?
Yes.
It would have been 500 Newton. So how much is the increment? The increase is going by how much percent? If you see this get cancelled into 100, 60 by 50, 600 by 50, that is around
180%.
180. No, not 120%. 120%. 120% increase. Right or not?
Yes.
Just by 2 meter per second square the acceleration. Okay? Now next case is number 2. When the lift is at rest or moving with, now this is the one. When the lift is at rest or moving with an uniform acceleration, uniform velocity. Uniform, have you seen, if you notice, a lift try to come down with a constant velocity, and when it is coming down, you hardly understand if you go to a very proper decent mall where they have installed a very high end um, lift mechanism, there you will see coming from one
Like
floor to another,
rectangle.
you hardly understand that you are coming down, right or not?
Yes.
Because they are
Yes.
planning to keep the velocity as uniform as possible, as constant as possible. Uniform velocity downward, velocity v downward, or maybe upward, same thing only. Okay, then what can I write? Definitely looking at the equation now. Now this acceleration equals to 0 means
Yes.
r minus mg equals to 0. So we have, I already taught you.
Yes, sir.
So your weight is exact. So I can ask you a different question. Later on I will see, when I do simple harmonic motion, I will keep a pendulum there and see what happens to its oscillations. Will it increase, decrease and all. Okay. So right now if I place a weighing machine, so you can understand the weighing machine is going to give abrupt reading, na?
Yes.
The third one. So here is your actual weight. When the lift falls freely, then when the lift falls freely, then what do you guess? What will happen?
So then R minus mg will be equal to mg.
R equal to, yeah, R, you can write like this, R minus mg will be equals to mg, right? So R equals to
Yes,
m,
sir.
g minus g. No. Falling
So R
freely,
will be
yeah,
equal to
falling
2
freely,
mg.
falling freely. Wait, falling freely. It is falling freely, na?
Yes.
So the acceleration is which side? So in this case it
Downwards.
would be downward. So in that case, what do you think it would be? R plus mg is equal to mg, or R is equals to 0. So
Yes.
the apparent weight becomes 0. The apparent weight, the apparent weight becomes 0. Okay?
Yes.
Right or not?
Yes.
Did you notice it is R plus mg
Yes, because it's free fall.
because it is freely falling freely. Now what will happen if acceleration is greater than, if a is greater than g, then the lift snaps and break. The acceleration is greater than g, then what will happen? You are inside the loop, you are inside the lift. The acceleration is now greater than g. What do you guess will happen now?
So
You can
going upwards.
you can see R plus mg will be equal to ma, right? So R is equal to m a minus g, a being greater. So what are you going to have now? You're going to have a reaction R. R is which side?
So we will be pulled out of the lift.
Wait. It will keep you going, taking you up.
Yes, sir.
You'll start floating for a while. Means you're coming up, right? And then you'll go and stick to the surface of the what? Surface of the
Lift.
elevator.
So lift.
You'll get stick to here. Understand? So this is the mechanism of the lift. Okay?
Yes.
May I clean it?
Yes.
A lift. Question.
So, but that will be when the lift is going downwards.
Falling freely. Yeah.
Yes. Yes.
With an acceleration greater than g.
Yes.
A lift of mass 2000 kg, that is 2 ton, is supported by no, let me not do this one now. Wait, I'll give another one. Okay, take this question. The weight of the lift, an elevator weighs 4 ton. An elevator weighs, WS weighs 4 ton. 4 ton means 4000 kg. Okay? When the upward tension in the supporting cable is 48 ton Newton, what is the upward acceleration? What is the upward acceleration? Second, starting from rest, how far does it rise? Does it rise in 3 seconds? Can you think about it? How to do it? Think about it. In your class, have they discussed this set of questions?
So we have not started this.
Which chapter is going on?
The third chapter.
Motion in a plane?
Yes, sir. No, sir, straight line.
Straight line.
Straight line.
How are they doing?
Fine.
Are you being able to answer your teacher's question?
Yes.
What kind of question been asked?
NCERT.
NCERT only, no?
Yes, sir.
Yes.
I hope you remember how to draw position time VT and AT graph. All
Yes,
the three.
Yes.
Is it a madam who is taking or a sir?
Yes, sir.
Sir.
None. Okay, let me do it. Elevator weighs 4 ton. When the upward tension, so I'll draw the free body diagram. You can see only showing the forces which is acting on the body. Okay, so weighs 4,000 ton. That means this is 4 ton, 4,000 mg, right?
Yes.
Upward reaction is R, but look, so upward reaction is given. There is also a tension to the elevator, right? So then upward tension is given to you also. There is a tension here. This is the tension. So these two minus will be responsible for my upward force. So F dash should be equals to T minus, as it is going up, definitely T is greater than mg. So T minus 4,000 into 10. Please at exam you do with 9.8. Okay. So tension is how much? 48,000.
48.
And this is 40,000. So that gives me 8,000 Newton. Right? What is the acceleration?
No, sir, that was 4,000, sir, not 40,000.
No, into 10 mg, na? So acceleration would be F by m. So 8,000 divided by m. M is how much? Mass will be 4,000. That gives me 2. Approximately 2. With 9.8 it may be greater. 2 meter per second square. I've got it. So that is the acceleration. Starting from rest, how far does it rise in 3 seconds? So t is given as 3 seconds. Acceleration I know. So I will use s equals to ut plus half so u is 0 or half into 2 into how much? 9. S equals to t square. Yeah, 3 square is 9. 9 meter. That is the answer. May I clear it? May I clear it?
Yes, sir.
This is your homework. An elevator weighs 800 kg. Find the tension T in the supporting cable when the elevator moves downward at a velocity 20 meter per second. So not moving downward with a velocity is brought to rest with an uniform retardation within a distance of with a uniform retardation is brought to rest with a uniform retardation in a distance of 50 meter. This is your homework. Do it later. Okay. May I clear it?
Yes, sir.
Sir.
Linear momentum and conservation of linear momentum. So conservation of linear momentum. We know from second law, I hope Newton's second law, we know F equals to mass equal to zero acceleration. If F is equal to, if external force is 0, F equals to 0 means what? Or I can write delta V by delta T equals to 0, right? Can I say M delta V equals to constant? Is it or not? I can say like this, or I can say in another way. In terms of, I can write like this also. Zero, or dp equals to constant. dp equals to 0, or p equals to constant. That is, change in momentum is always constant. Right or not?
Yes, sir.
Which you can write, in both the cases you can write P1 plus P2 plus P3 plus Pn, whatever be, you can have as many particles, no problem. It will be, sum will be constant. Right? Hence, conservation of linear momentum states. Hence, the law of conservation of linear momentum states. Hence, law of conservation of linear momentum, and is an extremely important law, states, what does it states? When no external force, when no external force acts on a system of, acts on a system of particles or a system, the total linear momentum, the total linear momentum of the system remains constant. Okay?
Yes.
So, may I clean it? I'll give an example. I'll give an example of this one. I'll clean now. Okay? Consider two objects. Consider two balls. Two spheres of masses m1 and m2, having initial velocity u1 and u2 is moving along positive x direction. They undergoes an head-on collision and then starts moving with I have one mass here v1. I have another mass here m2. This is also moving with velocity v2. It may be moving, it may not be moving, doesn't matter. We will deal with this in next chapter. Collision. Right now they undergo a head-on collision. Now this is possible only when u1 is greater than u2. Then only they will collide, or else they are never going to collide. Remember that. So as they collide now, the subject starts moving with a velocity of v1, v2. Then this is our initial system. This is our initial momentum, right? And this is our final momentum. Now this is the situation is very much happening in an isolated environment, so that no other process is involved in it. So what we can write, during collision, the spheres, what they do, impart equal and opposite forces on each other. That is, it will give like this: force on 1, 2 minus equal to minus 2, 1, right? Now this will be what? We can write this as dp. As a result, 1 will have force on 1 due to 2, so 1 will change, minus, can I write like this? Is it or not? dt get cancelled, so then this will be what? Change in momentum. Can I write this as delta p1 equal to, this is dp1, right? Delta change in momentum, p1. This is delta p2 minus. Then I can write delta p1 would be what? m1 final minus initial, v1 minus u1, and this would be minus m2 v2 minus u2. If I distribute this, I can write m1 v1 minus m1 u1 is equal to minus m2 v2 plus m2 u2. So then this can be written as m1 u1 plus m2 u2 is equal to m1 v1 plus, what I am writing. Am I doing right? Yeah, I am doing right. m1 v1 plus m2 v2. So this is the what? Initial momentum of the system. Equal to final momentum of the system. So this thing is staying conserved, which is nothing but our what?
Law of conservation of momentum.
Yes. Law of conservation of linear momentum. Okay? Let's see an example of this one. Have you copied?
Yes.
Yes, sir.
May I clean it?
Yes.
Yes, sir.
Recoil velocity. When a gun fires a bullet, the velocity with which the opposite velocity with which the gun recoils, means move back, velocity with which the gun move back is called recoil velocity. So if I give you, this is a gun Here I have the bullet. When you fire, so let m equals to mass of the gun, v equals to we'll do like this, yeah, recoil velocity, small m, mass of the bullet, v equals to velocity with which bullet is fired. Then what can I write? Initial momentum or the initial momentum, both of them are rest, right? 0. So final momentum of the system definitely would be mv plus mv. Therefore, using conservation of linear momentum, I'm just writing p vector, try to understand. I can write mv plus mv 0, or v gives me minus mv by m. This is the recoil velocity. Okay?
Yes.
So let's go to that AK-47 problem once again. So mass of, this is the statistics. Without magazine it's 3.4 kg and magazine empty is this 3.3, no? So around how much? Okay, we will take that as 4 kg. Clear? Or do you want to take this as, let me see. This is it, here you will find the details. I think we are going to get the weight to be somewhat with magazine. If I take the magazine also, magazine weights are 0.33 kg, no? 0.3, so 7. Let us take this as 4 kg. May I clean it?
Yes, sir.
Yes, sir.
Find the recoil velocity. Recoil velocity of an AK-47 gun if its mass is 4 kg, okay, and fires a bullet. What was the speed? That time we have done. Fires a bullet, let's say 500 meters per second. Fires a bullet of mass how much? 50 gram. 50 gram at a speed of 500 meters per second. Very easy. How you do? So V would be equals to minus mv by m. Solve and tell me how much.
Recoil velocity is 6.25 meter per second.
Make it in kilometer per hour.
So 22.5 kilometers.
Yes, this is more of understanding, no?
Yes.
So you have to always represent physics answer in such a way which you can translate, which you can understand. Meter per second never relates you anything, correct? You can now compare. Okay, 22 kilometer per hour means when a car is going at first gear or going slowly, not even first gear, second gear, right? Almost 20 kilometer per hour speed. That one. Now the question is, how you should hold the gun? You see, m by m, correct?
Yes.
Now, if this mass is more, right? Here you cannot change m, you cannot change v. One thing you can increase to reduce this. You can increase m. How can you do that? By holding the gun like this. Look at them. This gun and your body is together, is you have increased, you are giving your mass onto the gun. If you are not holding it tightly, I will show you, let me find out. I don't see, I think my keyword is not good. See, this can happen, right? So you have to hold it in such a way that you have to be careful. You have to be extremely careful while holding it properly, right? Because that's 6 kilometers. So you have to give your mass. You have to skillfully have to hold in such a way. You have to increase this mass. Because if you increase this mass, you'll see. You would hold it properly and tightly. Then you'll see the recoil velocity will get reduced, right? Because v is inversely proportional to m. So if I plot the curve will be something like this. It's a rational function. In the rational, this curve is common throughout. As is a rational function, you can see that as m increases, what will happen to v? V will decrease. But if small m, capital M decreases, v will be more. So if you try to hold the gun very far away from your body and then fire, you will get a huge back recoil velocity. But again, when you hold it to your body properly and steadily, definitely you will get what? You will get less impact, right? Other example of conservation of momentum will be. So what should you conclude? That the gun should be held very tightly to your shoulder, right?
Yes, sir.
Okay, other thing is that, another example, so this was one example of conservation of linear momentum. Another example of linear momentum will be, if this is a bank, river bank, This is a boat. This is gradually going that side. It is gradually coming towards the bank. Now if a person jumps from here, if a person jumps from here to here, right, what will you see? As soon as the person jumps from here to there, what will you see? This one will go back, right?
Yes.
Slightly moves away. So another example will be, I leave this for you to explain. When a man or when a person jumps from a boat to the shore, the boat slightly moves away. And the most important, rockets and jet planes. Rockets are planes. No, jet planes. Works on the principle of here.
Yes.
Yes, sir.
Another thing is that you have a bomb here. You have a bomb. When this bomb blasts, it gives debris in all direction, no?
Yes, sir.
Yes, sir.
So let's say this is M1 V1, M2 V2, M3 V3, M4 V4. Interestingly, then if you one, two, three, four, five, six, P1, P2, P3, P4, P5, P6, polygon. Sum of all the momentum is what? 0. Clear?
Yes.
Yes, sir.
Sum of all of them is 0.
Yes, sir, because they will cancel.
Clear? May clean it?
Yes, sir.
This is also your homework. A 30 kg shell flying at 50 meter per second explodes in two parts. One part of 1 part of 20 kg stop, while the remaining flies on. Find the velocity of the latter. Okay?
Yes, sir.
Yes, sir. So what step find the velocity of the
Later. Next question. A 30-gram bullet leaves a rifle. Zero point 0.6 meter per second. That would be enough. Okay.
Yes.
That would be it for today. This much.
Yes.